Hello viewers, this is the Science Demystifier number 1 tutor. So always here at this particular time of the year to give you the theoretical evaluation of WASSCE chemistry practicals volumetric analysis. So we are here again. Please, I want you to draw close. If you are a teacher, if you're a student, just follow this practical guide I want to give to you because it will help you not to beat about the bush, so you know what to expect in your titration experiment. So please do well to share this video to as many that will need it. And if you're not following me here on YouTube, please do well to hit the subscribe button, turn on the notification bell, because I will be doing more on chemistry practicals as the exam date approaches. So you need to do what? Hit the subscribe button, turn on the bell notification. If you're not also following me on Facebook, please do well to follow me on Facebook, because I have a lot of useful content like this for you. So let's go and demystify the process. In the theoretical determination of our endpoint for this year's chemistry practicals 2026 volumetric analysis, we are provided with this data. And with this data, we are going to use it to unmask the endpoint of this year's titration. Now we are given 5.0 cm cube of H2SO4, which contains 98% purity of the stock solution, and the relative density of the solution is 1.84. We are also given 4.0 grams of the base, which is sodium hydroxide, in 1 dm cube of the solution. So the first step in solving this calculation is for us to find the mass of H2SO4 in the solution. So that can be done using the formula mass equals density times volume. Mass equals density times volume. So the density of the solution is 1.84. We are going to multiply it by the volume, which is 5.6. So when we multiply the density of the solution by the volume, we'll get approximately 10.3 grams of the stock solution. Now the second step of our calculation will be for us to convert this mass that we have gotten to mole. Convert the mass to mole. Of course, you know that mole is equal to mass, reacting mass over molar mass. So when we have 10.3 divided by the molar mass of sulfuric acid, which is 98. So when we divide 10.3 by 98, that will give us that will give us 0.105 mole. Now, since we are to get the concentration of the acid per dm cube of the solution, so we're going to be dividing this value by the volume of the solution, which is 1 dm cube. So in 1 dm cube of the solution, we'll get the same value, because anything divided by 1 is still that thing. So when we divide 0.105 divided by 1 dm cube, that will give us the expected concentration of the acid, which is 0.105 mole per dm cube. So that is your Ca. That's your Ca. So the next step in our calculation will now be to calculate the concentration of the base, which is sodium hydroxide. So to find the concentration of the base, we'll simply use the data provided. We are given 4.0 grams of sodium hydroxide in 1 dm cube of the solution. That is obviously the mass concentration. So to find the molar concentration, we'll do mass concentration, mass conc over molar mass, mass concentration over molar mass. So which will now give us the mass concentration is the 4 gram per dm cube. Now divided by the molar mass of the sodium hydroxide. So that will give us 0.1 mole per dm cube. So this one is very easy to compute. So we have gotten our CB, which is the concentration of the base. So we are now going straight to the titration equation so we can determine the VA. That is, from that equation, CAVA over CBVB is equal to NA over NB. So it is the VA in that equation that is the expected endpoint which we are looking for. Applying the titration equation, CAVA over CBVB equals NA, number of moles of acid over number of moles of base. Now don't forget that the equation for the reaction involving sulfuric acid and sodium hydroxide is this. So when they react, you will get the salt, sodium sulfate, then plus water. So to balance the equation, because of sodium, I need to put 2 here. To balance the equation. So that means that number of moles of acid that reacted is 1, number of moles of base that reacted is 2. So don't forget that concentration of the acid, we got the value as 0.105 mole per dm cube. And then we got the CB, concentration of the base, as 0.1 mole per dm cube. So we can substitute all these parameters in this equation for us to be able to calculate the VA, which is the endpoint, the expected endpoint. Substituting, we have 0.105, which is CA, times VA, all over the concentration of the base, that's 0.1, times the volume of the base is the volume of the pipette that your school will use on that day. Some pipettes have 20 cm cube capacity, some have 25, but the common one is the one that has 25 cm cube capacity. So we have 25. Now that's equal to number of moles of acid, which is 1 from the equation, number of moles of base, which is 2, so we can cross multiply. So when we cross multiply, this times the whole of this will give us 0.21 VA. And then 0.1 times 25 times 1 will give us 2.5. Then our VA now will be 2.5 divided by 0.21. And that will give us 11.9 centimeter cube. So this is the ideal endpoint for this year's volumetric analysis or titration. So this is, be you a teacher or a student, so this will serve as a guide. So if your value is around this figure here, 11.9, that means you did the right thing. But it must not be exactly 11.9 due to errors that goes with concentration, dilution of solutions and all whatnot. So it might not be exact, but this is the ideal endpoint. So thanks for listening. God bless you.